to like tail-f, you print to standard output, and you're also waiting for new input. So one thing with event-based parsers to consider, though, is if you run into malformed content, you crash your parser. So we're going to have to clean up the markup and make sure that it validates.
There's two event-based parsers out there, both push and pull types. The push type is typically SAX, and the pull type is usually just called a pull parser. There's like an implementation in Java called Stacks, which is a pull-based parser. Normally, like the libraries that we showed you support all three types, like a DOM tree-based style parser, and a push and a pull parser.
So if you ever dealt with the malformed content, it's not really fun. There's a couple tools we can use to fix our markup, like HTML tidy. The user doesn't see broken markup because our browsers do a pretty good job of fixing that and abstracting that from the user so the web pages aren't broken. Probably IE would be the best example of that, but there's other libraries you can use.
Sure. So there's lots of different libraries for fixing up markup, especially bad HTML markup. If you have valid HTML, that's great, but it's normally really difficult to do. Like, for example, on our website, we had completely valid XHTML, on our machine, and it all worked fine. But then when we uploaded to the server, it was no longer valid, and we can't figure out why. So you're still going to run into lots of situations where you need to have valid markup. And one of the libraries out there that's been known for a while is HTML tidy. It's a C library, but it has bindings for other languages, like even Ruby and Perl and Python and pretty much everything. There's other libraries that kind of encapsulate that concept with parsing, and so they'll do both at the same time. So you don't need an XML parser and a markup fixer separately. Two that I know of are Beautiful Soup and Rubyful Soup, but they're both kind of slow in comparison to other parsers. Some of the best parsers kind of trade off a little bit of efficiency and perfectness and correctness with more speed. Like Nico HTML is one of the best ones. That's what Anti-Sama uses, and lots of other big projects use Nico HTML, which is mostly Java, but can be externalized from Groovy and other languages as well. Another popular Java one is TagSoup, so those you should definitely know about.
All right, so when we're dealing with malformed content, we need to deal with that before when we're using application drivers there. And that brings us to three different drivers we could use. There's protocol drivers. I'm sure a lot of you have used curl. It speaks HTTP back and forth to the server. Some application drivers are HTML unit, JWeb unit, and WebDriver. And there's some difference between application driver and protocol driver is application drivers have some understanding of JavaScript, mostly the logic, but not the behavior part of JavaScript. And a browser driver like what's here, Selenium or WebDriver, they pretty much put your browser into autopilot like Firefox or IE, and because you're using a browser, you're driving your browser, it has a full implementation of JavaScript, so you can do all kinds of stuff in there. So some Firefox stuff we use with XPath stuff and testing. Firebug, I'm sure most of you've used Firebug. We really like XPather. It gets really nice XPath expressions. There's another tool, XPath Checker, but it's more loose in how it identifies an XPath. And you could use XPath Checker with View Source Chart pretty well. And Selenium IDE is an extension for Firefox to use Selenium. And let's see. So we use the XPath extensions to get the location of our elements in our body for when we're testing. And we're going to start building some tests in Selenium. Selenium IDE lets you record and playback your interaction with a web application straight from Firefox. So I would demonstrate it here, but something, just, I don't know, tech problems. But we can record it and then play it back. And all our interaction is saved in an HTML table. And because Selenium is a table-driven testing tool, we can make changes to it. And that brings us to, let's see. I don't know how the screen's on here. Oh, the screen's on here. Shit. All right. That brings us to Selenium Test Runner. Selenium Test Runner actually is just static files with JavaScript on them that you load into a web server directory, and you call various test suites that you've created with Selenium IDE. And then you could also add some actions and assertions to your test to perform multiple different things. And then you can run these Selenium tests now from any browser, including IE, Safari, Opera, Firefox, whatever that can support, whatever browser you have that can support JavaScript. We had an example exploiting DOM XSS from the XSS attacks book, the awesome.html that was written by PDP. We did an example of bypassing the input validation with Selenium, setting a cookie in the DOM, and then verifying if the cookie exists, and then deleting the cookie afterwards. The only drawback to doing DOM-based event testing is you have to wait for the entire DOM to load. So your Selenium tests aren't running as fast as it would if you were just looking for the content to be returned. And you got to slow the test down a little bit for DOM-based stuff. I had a demo here, and sorry you guys can't show it unless you have Selenium. No. Excuse me?
What's it? What's the question?
No, so you can bypass well, let's see.
What we wanted to show with Selenium that we can't show here today because we had to change laptops, and his laptop was not inputting properly, and mine really wasn't either. But basically, what we're trying to show is that the tool is capable of DOM-based XSS. A lot of web application scanners just recently added this functionality, maybe a year ago, maybe a little bit less. And with Selenium, you can actually go in and affect the DOM as much as you want. So any of the JavaScript, any of the CSS, any of the HTML, and you can input things on the DOM that would be running in, say, Ajax applications, or possibly even Flash or other applications like ActionScript languages. So that's what's really interesting about it. It's an open source tool. It's in the browser, and the exploit that we wanted to show is basically from the XSS attacks book. You could download Selenium yourself and probably try out that attack. Marcin figured it out in an afternoon, so it's really not that difficult.
Yeah, it was client-side input validation. It was, what is it, PDP was pulling jQuery and just wrote some JavaScript to return back exact name. You input a name, it gets returned back from there. I was running all on localhost, so it's no server-side, but you can do server-side input validation with it.
Yes, but WebScarab is only a protocol driver, so it doesn't have an application driver functionality, so it cannot affect the DOM.
So I wish I could have showed you what the test looks like, but it was literally 44 lines of HTML table. Every event we tested was a single TR table row, and you have your action, what you're affecting, and an argument in table data cells. It's just a taste of what you can test for. What you really want to be doing is you want to be testing for illegal characters, so like less thans and greater thans. Make sure those aren't being returned to the client, and you want to check for those characters and have them encoded, double encoded, triple encoded, etc. And basically validating input or checking to see if your input validation is working correctly. and you don't have to waste time with the XSS or SQL injection cheat sheet.